All right, welcome to week 5, practice problems. First question says, what is the average of A, B, and C given that 2A plus 3B plus 4C is equal to 4 and 3A plus 4B plus 5C is equal to 20? Okay, so this problem looks like a system of equations. The problem is it's got 3 variables, so we're not really sure how to actually graph this thing. The other thing is it says what is the average of those 3 numbers. So it doesn't say find the solution. It doesn't say find A, B, and C. It says find the average. So if you think about it, if you have 3 numbers, A, B, and C, the average would be A plus B plus C divided by 3. Okay? Now we don't have anything close to this, but when you're working with systems, you got to be able to look for patterns. Like, can I add a certain number of this equation or subtract this equation to get what you want? So if I want A plus B plus C, I need to look for that, okay? So if I look at 3A plus 4B plus 5C, and I look at the other one as 2A plus 3B plus 4C, if I subtract these 2 equations, so if I take 3A plus 4B plus 5C and I subtract 2A plus 3B plus 4C equals 4. So basically I'm going to multiply everything by -1. That's going to give me -2A minus 3B minus 4C is equal to -4. So basically I'm going to cross that one out because I've changed this first equation into what I need it to be, because now I can add these 2 equations, right? I can add this equation and this equation together. So I'm going to add those 2 equations together. 3A plus a -2A, that's just A. 4B minus 3B, that is B. 5C minus 4C, that is C, and that equals 16. Now, remember my goal is to get A plus B plus C divided by 3. And I don't have that, but I do have A plus B plus C, which is the hard part. So how do I convert this thing into A plus B plus C divided by 3? Well, remember in algebra, you can do whatever you want as long as you do it to both sides. So if I divide both sides by 3, on the left side, I've got the average. This is the average of A, B, and C. That's equal to 16 thirds. So 16 thirds is 5 1/3, and 5 1/3 is answer choice C. Okay, so just remember, sometimes when you're dealing with when you're dealing with systems, that you can manipulate the system to look like what you want to know. Like if for some reason it said, what is 5A plus 7B plus 9C equal to? Okay, if that was the question, I would look at those 2 equations and say, oh, look, if I added those 2 equations, I would get that expression right there, this 5A plus 7B plus 9C. So then on the other side, if I added 4 and 20, I would get 24. So that would mean the sum of those expressions are equal to 24. So just be on the lookout for things like that. This is definitely something that you can utilize on the test. All right, find the points where the graphs of y equals 2 minus 2x and y equals -2x squared plus 2 intersect. All right, so you could solve this like a system because you have 2 equations with 2 variables. That usually means you can solve it. So what you could do is you could say, okay, I'll write the first one down. I'll write the second equation down. And then notice that I've got one variable solved for already. I've got y by itself. So if I've got y by itself, that means I can use a substitution here. So y is the same thing as 2 minus 2x. So if I rewrite the second equation as y equals -2x squared plus 2. Notice when I said y, I didn't write y. I wrote what y was equal to. What this does is put the equation into one variable. So I can solve this now. This is going to be a quadratic. So what I'm going to have to do is get everything on one side. So if I add 2x squared on both sides, I'm going to get 2x squared minus 2x plus 2 is equal to 2. And then I subtract 2 to get it over here. What that does is gives me 2x squared minus 2x equals 0. All right, now I can factor this There's a common factor of 2x. So I pull it out front. I'm left with x minus 1 equals 0. Then I can solve. I can say the first term is equal to 0. The second factor is equal to 0. And I solve both of these. I get x equals 0 and x equals 1. Okay, x equals 0 and x equals 1 is part of the problem. I need to know the y values though. So I go back up into one of my equations. I'll pick the first one. You don't have to, but it's just as easy. Plug in 0 for x. You get y equals 2 minus 2 times 0. That gives me 2 minus 0, so y is equal to 2. So when x is 0, the y is equal to 2. That's going to be one of my solutions. When I plug in x equals 1, I get y is equal to 0. Okay, and again, that's because I have y is equal to 2 minus 2 times 1. 2 times 1 is 2. 2 minus 2 is 0. So the y value is 0. All right, so that's a lot of work, but it's doable. There's a much easier way to solve this problem. Well, first of all, let's talk about what our answer is. X equals 0, y equals 2. That is going to be this first part, and then x equals 1, y equals 0. Those are my two solutions there, is E. 0, 2, and 1, 0. But again, this problem is much, much easier to solve using your graphing calculator. Because they're already solved for y, this is actually pretty simple. So I'm just going to graph the two functions. So y equals 2 minus 2x, and then I graph the second one, negative 2x squared plus 2. All right, hit graph. You're going to see the two graphs. So what we're looking for is when do these 2 points intersect? So I can zoom in here, right? Zoom 2, hit enter, and I can see that it's at 0 and 1, right? 0, 2, and 1, 0. If you weren't really sure or couldn't tell, you could verify that by looking at the table. When x is 0, both of the y values are 2. That means they're intersecting. And when x is 1, both the y values are 0. Now let's say you didn't feel comfortable looking at the table. You could go back to the graph and do second trace, which is calculate, second trace. Number 5, the intersection. So you hit number 5, and then basically you hit enter 3 times. There's your intersection, 0, 2. Okay, now when I say hit enter 3 times, that's kind of a shortcut, but let's see if I want to find the other value, it won't work like that. I'll have to do second trace, number 5, and then enter, enter. And then here where it says guess, I use my left and right arrows to actually go down to where the second intersection point is. Now, if I hit enter that 3rd time, it gives it to me. If you just hit enter, 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 it will find the nearest one to where your cursor already was, this little blinking cursor. All right, so that's, I think, the best way to solve this. And again, how do you know to use this strategy? I think the most obvious thing is that it says y equals blah, y equals blah. It's solved for y. That's a really big indicator that this would be really, really easy to do on your calculator, okay? Now, third way to do this, you could plug in numbers to see if they work. Like, for example, 0, 1 in choice A, plug it in. When you plug in to the first equation, y equals 2 minus 2x, you plug in 0 for x, you should get a 1 for y. So 1 equals 2 minus 2 times 0. This should be true. 1 equals 2 minus 0. So that's not true, which means 0, 1 is not a solution. So you can say it's not A. You could go through this process and test all these points and eliminate choices until you get to the one that has the ones that work. But I still think the fastest way is with the calculator. All right. Moving on. Which of the following is true about the 2 lines listed below? Okay, so this question is obviously asking if they're parallel, perpendicular, if they're the same line, or if they just intersect in a normal way. So what we need to do is we need to know the slope. So remember, you don't have to worry about anything other than solving for y and moving the x over. So I'm going to move this x over by subtracting 3x from both sides. That gives me 2y, well, there's a plus 4 there, equals negative 3x. Now we saw it's actually okay to just move this number over as well. So I subtract that over, divide everything by 2, divide everything by 2. This is the slope of the first line, okay, negative 3/2. I do the same thing with the second line. 2x minus 3y plus 12 is equal to 0. Go ahead and, I'll go ahead and subtract my 2x over. That gives me negative 3y plus 12 equals negative 2x. I'm going to go ahead and move my 12 over just in case these lines are the same line. I don't want to run into that problem. Then I divide by negative 3. Divide by negative 3. Divide by negative 3. These are both negatives, so they turn into a positive 2/3 is the slope, and my y-intercept is that 4. Okay, so looking at the two slopes, are they equal to each other? No. Are they negative reciprocals or negative flips? Yes. That means they are perpendicular to each other. Again, the only way I can find that out is by solving for y in both of these equations. If I put it into that form, I can look at it and immediately tell you what the slope is. So we're going to say the answer choice B is correct. These lines are perpendicular to each other. Now you could solve for y and graph it, but that takes too much time. It would work if you didn't feel comfortable about this. But again, either way, you have to solve for y. All right, which of the following statements describes the solution set of the inequality? Okay, so this is a basic inequality that we just need to solve for x. So first thing I do is I distribute my negative 6. So I get negative 6x plus 18. Okay, those two negatives multiply to make a positive. That's greater than or equal to. I distribute the negative sign into both parts. Remember, the negative sign just flips the sign of the thing. So positive x becomes negative x. Negative 5 becomes positive 5. And then I've got this plus 8 at the tail end. All right, so start moving all your x's together. I move this over by adding x to both sides. That cancels. This simplifies to be 13. So I have 13 on the right side. Over here, I have negative 6x plus x. That's negative 5x plus 18 is greater than or equal to 13. All right, so I got to start solving for x. Let's get rid of the things around the x. So I'm going to subtract the 18 over. That makes it disappear. I'm left with minus 5x greater than or equal to negative 5. All right, last step is to divide out the negative 5. Don't forget, when you divide by a negative or multiply by a negative, you have to flip the sign. It's really important that you flip that sign around because I multiplied or divided, not add or subtract, just multiply or divide. So I get x is less than or equal to 1. Okay, so we're going to say choice D is the best answer. X is less than or equal to 1. This one you actually could graph. You can actually solve inequalities by graphing. It's not terribly impossible. Let's look at it real quick. You just graph the left side, graph the right side, and we want to find out when the left side is bigger or equal to the right side. So what we could do is we could say, okay, y equals, we graph the left side, negative 6 times x minus 3. Go down here, plot the right side, so negative x minus 5 plus 8. Then you hit graph. Okay, my zoom's all messed up, so I'm going to hit zoom standard. That's zoom 6. There's my two lines. I can't really see what's going on, so I'm going to hit zoom out. Got to hit enter one more time. There we go. So if you look at here, it looks like they cross at 1. And which one is our left side? Our left side is the minus 6 part. So that is right here. So minus 6, that's the blue line on mine. So I want to know, when is the blue line bigger? Well, it's taller, it's further up to the left of negative 1. Okay, so to the left of negative 1 is everything less than negative 1. So you would say, oh, okay, D, everything less than, positive 1. Also, you could look at the table. Okay, the blue line is not bigger over here when x is 4 or 5. Right, we're looking to see, oh, right here at 1, they're equal, and then everything less than 1, the blue line is bigger. So that's what we're saying. We're saying the left side is bigger when x is less than 1. So again, that reinforces why we get D. All right, next question. Which of the following is an intersection point of the following graphs? Y equals x squared minus 3, y equals negative 0.5 x squared plus 3. All right, so they're asking for the intersection point. So you could use substitution, and you could say that, okay, if y is equal to x squared minus 3, then in the equation y equals negative 0.5 x squared plus 3, I can replace this y with what it's equal to. So you get x squared minus 3 equals negative 0.5 x squared plus 3. You add 0.5 x squared to both sides. You get 1.5 x squared minus 3 equals 3. We add 3 to both sides to get this to go away. We're left with 1.5 x squared equals 6. Divide by 1.5, we get x squared is equal to 4. Well, if I square root both sides, I get x is equal to 2 and x is equal to negative 2. Don't forget the square root of a number is always positive and negative versions. Okay, then I'd have to plug that in back up into here, and I would say, okay, let's say 2. 2 squared is 4. 4 minus 3 is 1. So the corresponding y value there is 1. So 2, 1, but I don't see 2, 1 in my answer choices, so I try the other one. Negative 2, I plug it in, negative 2 squared is 4, and 4 minus 3 is 1. So negative 2 positive, or excuse me, negative 2, negative 1 is also a solution. So there we go, I say it's D. Now, most people aren't going to do this like this. Most people are going to graph this, and I think this is probably the easiest way to do this problem. Okay, since y is already solved for, it's easy to plug in. I get x squared minus 3. And on the other side, I get negative 0.5 x squared plus 3. Graph them both. There's the intersection. I can look at the table to find the intersection. Remember, we're trying to find when the y's are the same. So when x is negative 2, the y's are both 1. And when x is 2, the y's are both 1. So it's negative 2 and 2. Those are the intersection points, negative 2, 1, and 2, 1. Again, you can look at the graph, but it's a little sketchy. That looks pretty clear there that it's negative 2, 1. But again, I could do second trace, number 5, and then enter, enter, enter. That will find one of them. There's the first one, 2, 1. Then I do second trace, number 5, enter, enter. And then don't hit enter the third time. You got to move your little cursor closer to where the other intersection point is. Hit enter, there's your other one. Okay. All right, moving on. Which of these equations represents the following graph? All right, so I have an inequality that's in standard form. Easiest way to graph this would be to find the 0. So let x equal 0 and find the y number. So when x, well, let's just look at this actually. If I look at the graph here, I can see that my y-intercept is negative 2 and my x-intercept is 1. So that's what I'm looking for, okay? So in the first equation, when x is equal to 0, right? When x is 0, this goes away. You're left with y is equal to, y is equal to 2, right? So that's not going to work because this is down here at y equals negative 2. This is y equals negative 2. So we can say that choice A is not a possible choice. We're going to say it's not A. So look at B. When x equals 0, right? When x equals 0, this goes away. We're left with y equals 2. Again, it can't be that, so we're going to say it's not choice B. All right, choice C. When x equals 0, this goes away. We're left with y is equal to negative 2. That's possible. So far, that's fitting our scenario. Okay. And then on the other half, we say, okay, when y is equal to 0, this goes away and x has to be 1. That works. So that one's possible. That combination of 4x and minus 2y and that 4 on the other side works. But if you notice, there's two different equations that have that. It's just whether it's less than or greater than. So here's where you got to decide which side to shade. Pick a point on either side. Okay, I always like 0, 0. Super duper easy to test. So we have the equation 4x minus 2y is greater than 4. If we plug in 0 for x and 0 for y, we get 0 minus 0 is greater than 4. Well, 0 minus 0 is 0. Is 0 bigger than 4? No. That means that is not our equation because that is not true. This is saying that 0, 0 is not a solution, because that's not true. But if you look at your graph, 0, 0 should be a solution because it's in this shaded region. Okay, so that means it can't be C, therefore it has to be D. Now just to double check, when we plug in 0, 0, oops, 2 times y is less than 4, I get 0 is less than 4, which is true, showing that 0, 0 should be a solution, and that's why we say that that's shaded to the correct side. All right, which of the following graphs is the solution set to the compound inequality 4 less than negative 2 times x plus 1 less than 12? All right, so this is a compound inequality. So we solve it at the same time. We solve for x, which is usually in the middle, by using our normal algebraic operations, and then we analyze the result. So first thing I want to do, you could distribute here, okay, or you could just divide out the negative 2. If you divide out the negative 2 on all 3 parts, you would get negative 2 is less than x plus 1, which is less than negative 6. Then you would subtract 1 from both sides, well, all 3 sides. So you get negative 3 is less than x, which is less than negative 7. Okay? Now, if you distributed first, you would just get 4 less than negative 2x plus 1 less than 12. Then you would subtract the 1 first. Sorry, this would be negative 2. And you distribute. So you would actually add 2 to everything. Excuse me, that was my mistake. That gives you 6 less than negative 2x less than 14. But when you divide by negative 2 on everything, you're going to get negative 3x and negative 7. And I forgot to mention something here. We should have flipped the sign. When I divided by negative 2, I should have flipped the sign. So let's see how this actually should be our answer. So right here, these are incorrect. These should be greater than symbols. Because right here, when I divided by negative 2, that should have changed these to greater than. Okay, just don't forget that's the one special rule about solving inequalities. Okay, so what you got to do is look at this compound inequality. Basically, mathematicians are being lazy. This is really what is happening here. There's 2 little inequalities shoved into one. Okay, so the first one says, I always rewrite my inequalities with my variable on the left side because it makes more sense to me. X is less than negative 3. Okay, x is less than negative 3, and x is greater than negative 7. Okay, so if that's the case, I'm trying to see here. Yeah, so x is less than negative 3 and x is greater than negative 7. What would that graph look like? Well, starting at negative 3, we're saying everything less than negative 3. Okay, and everything bigger than negative 7. Now, if you think about that, negative 7 is smaller, so everything bigger, they kind of meet together in the middle. So it's actually going to be A, because everything bigger than negative 7 is all this stuff, and then everything less than negative 3. So basically, it's saying everything in between negative 3 and negative 7. Okay? If it had said x is less than negative 7 and x is greater than negative 3, then it would have looked like more like B. Oh, I'm sorry, it's not A because A is filled in circles, right? See how this is strictly less than or strictly less than on both sides? That means we actually want to choose A, or E, sorry. So the answer choice E is correct because of the open circles. When you have less than, you're not allowed to equal the endpoint, and that's why we have those open circles. So make sure you're paying attention to that. I almost fell into that trap there. But like I was saying, if for some reason you had had it the other way, where it was less than negative 7, it would look more like B, less than 7, but bigger than negative 3. That would be where it goes out. It either goes inside or outside when you have these compound inequalities. All right. All right, for what values of x and y does absolute x plus y equal absolute x minus y? All right, so this is kind of a tricky problem. You have to really think about this one. First of all, let's look at choice A. There are no values of x and y. Well, what if x was 0 and y was 0? Isn't it true that absolute 0 plus 0 would equal absolute 0 minus 0? Right? Absolute value of 0 is 0, and that's the same thing as the absolute value of 0, which is 0. So in that case, you can say, well, it's not A. I can find at least one value where it works. B says every value of x and y. What if x was equal to 10 and y was equal to 100? Right? You can see pretty quickly that when you add those together, you get 110. When you subtract them, you get negative 90, which absolute values to 90. So those aren't going to be equal. So it's not every value. Right? So you can eliminate choice B. C says all values where x equals y. So let's try one of those. Let's try 3 and 3. Okay, you get 3 plus 3, and then you get 3 minus 3. You can see that that's going to be 6 and that's going to be 0. So if x and y are equal, it doesn't work either. Okay, so again, we're just testing points to see what works here. Now D says when x is equal to 0 and y is equal to 0. Okay, that's true, but is it possible that E is the answer when x is equal to 0 or y is equal to 0? So that's saying x is equal to 0 and y is equal to another number. Okay, let's try something like this. When x is 0, we get the absolute value of 0 plus 10. And what we're claiming is that maybe that equals 0 minus 10. Okay, I'm plugging in y equals 10 and x equals 0. Well, that works. The absolute value of 10 is equal to the absolute value of negative 10. So in that case, as long as x is 0, y can be anything it wants to be. It'll still work. And if you checked it the other way around, it would work as well. So because we're allowed to have just either one of those, it could be both, but either one would be the best answer. So we're going to say E when x is 0 or y is 0. All right, next problem. Find the slope and the y-intercept of the equation x equals 3y minus 10. All right, so if we're finding slope and y-intercept, we've got to solve for y, right? We want to put it in slope-intercept form. So you've got to solve for y. So that means we need to add 10 to both sides. That makes x plus 10 equals 3y. Then I need to divide out the 3. Remember, I basically just divide everything by 3. 3's cancel there. I'm going to write the y on the left side just because it's what we're used to. Don't forget x divided by 3. The coefficient of x right there is a 1. So really, I'm going to write the x off to the side. 1/3 x plus 10 thirds. All right, so once it's in this form, it's easy. Slope is 1/3. Y-intercept is 3 and 1/3. Remember, you can do this on your calculator. If you ever were unsure, you can test that. 10 thirds is equal to 3 and 1/3. So our answer is going to be choice C. Okay. Just remember, you can't get anything from this. If y isn't solved for, you don't know the slope and you don't know the y-intercept. You've got to solve for y. All right, for what values of x does absolute value of negative 2x plus 4 equal negative 12? All right, this one is really tempting to start writing out, right? The way that we write this out is we write whatever's inside the brackets equals the number, and then we do the same thing. We rewrite it, but then we switch this to a positive. Okay? Unfortunately, you've got to keep an eye out for this. You can never take an absolute value of a number to equal a negative. You never do absolute value to equal a negative. It just won't work. Every time you absolute value something, it becomes positive. So there's no way to get the left side actually equal to the right side. You could solve these two equations and they would give you two answers, but when you plug those answers back in, it'll never quite work. So they call those extraneous solutions. They're numbers that look like they might work when you use the kind of the formula, but it doesn't actually work in actual practical use. So we're going to say E, there are no solutions. Just watch out for absolute value equaling a negative. Okay? The same thing would happen if I had x squared equals negative 4. I can't, every time I square a number, it becomes positive. So there would be no solution here, unless, of course, you're talking about negative roots, which do exist if we're talking about imaginary numbers, but we'll get to that at a later time. All right, find the equation of the following graph. All right, so this one's pretty quick and easy. All the answers are in slope-intercept form. So I find the slope and the y-intercept. The y-intercept is going to be -2, and the slope is going to be rise 2, run -4. Rise 2, run -4. That simplifies to be -1/2. That is my slope. Remember, slope is the number in front of the x, and so we get answer choice B as our answer. -2 minus 1/2 x. Don't forget, they can put the x in front of the number or x in back. It doesn't matter. It's always the number with the x is the slope. The number by itself is -2. And also don't forget, the only reason I'm allowed to use that information is because y is solved for. Y is by itself. Therefore, I get to extract that information immediately without really thinking too much about it. All right, for what values of x does absolute value -x plus 5 equal 9? All right, so this one is possible because you can take the absolute value to equal a positive, unlike the problem from before. So what you do is you break it up into two equations. The first one, you basically just drop the absolute value bars. The second one, you drop the absolute value bars, but you switch the sign of the 9. Because basically anything in that absolute value, if it was equal to 9 or -9, would be a solution. Because the absolute value would get rid of that negative, okay? So we just subtract 5 from both sides. We get -x equals 4. We divide by -1. We get x is equal to -4, okay? Over here, we do the same thing. We get -x is equal to -14. When we divide by -1, that changes the sign to a +14. So -4 and 14, we're going to say answer choice C is correct. -4 and 14 are the values of x that make that equation true. All right, write the equation of a vertical line passing through the point -8, 7. All right, if you remember vertex, okay, vertical lines are always x equals a number. So when you think about where -8, 7 is, it's right here. The vertical line passing through there has all points have x values of the same x value. So we want to just say x equals -8 is the equation of that vertical line. Every single point on here has an x coordinate of -8. So the equation just has to say x equals -8. It doesn't matter what the y is. The only thing that matters is the x coordinate. So that means D is our correct choice. All right, find the solution set of absolute 1 minus 2b greater than 3. All right, so when we deal with inequalities, it's very similar to the equation. We write it without the bars, but then we have to remember to do a flip-flop. We flip the sign and we flop the value of that number over there and make it negative. Okay, whatever that number is, we got to switch the sign of it. Now we just solve. So subtract 1 from both sides. If I subtract 1 from both sides, I get -2b is greater than 2. When I divide by -2, I have to flip the sign, right? Because I divided by a negative, and that leaves me with b is less than -1. Over here, very similar. I take away 1 from both sides. I get -2b is less than -4. If I divide by -2, since I divided, I have to flip the sign. I get b is greater than 2. Now, which one of these is it? It's going to be B. Okay. Pretty straightforward. You could use your calculator on this, where you graph the left side and you graph the right side, and you find out when the left side is bigger. It would work. I think this one's much easier and faster if you can just do it by hand, but that would work. That strategy of solving an inequality based off of using your graphing calculator, that could work for you here. All right, what is f of 3? All right, so this is a piecewise function. We just have to know which of these three things to plug into. Is x less than 0? No, we're talking about x is equal to 3. Is x greater than 0? Yes, we're wanting to plug it in there. So we take, basically, we only use the part that we need, so 2 absolute value of 2 minus x. We're going to use this little piece here. So when I plug in 3 for x, that means I plug in 3 for x everywhere. and I evaluate. So 2 times the absolute value of -1, absolute value of -1 is 1, 2 times 1 is 2, so f of 3 equals 2. So we're going to go with choice C, 2. All right, which of the following graphs shows the solution set to the statement 3 less than 4 times b is at most 13? All right, so this is an inequality that's written in words, so we have to convert this into an equation. Really the hard part here is that don't get caught up in this trick. 3 less than 4 times b is at most 13. 3 less than 4 times b is not written this way. When you have 3 less than something, you have to take away 3 from it. So you actually make sure that you do 4b minus 3. Okay, that's the first hard part about this. When you have 3 less than something, you take away 3 from it. Last thing is at most. It's at most 13. Can it be 14? No, it was at most 13. Can it be 13? Yeah, it can be 13. It's at most 13. So it can't be anything bigger than 13. It has to be less than 13. So we would say less than 13. The question is it allowed to actually equal 13? Yeah, at most means it can't be bigger than 13, but it could be 13. So that means we need to make this less than or equal to 13. Now, solving this is pretty straightforward. Add 3 to both sides. We get 4b is less than or equal to 16. When I divide by 4, I get b is less than or equal to 4. So all I got to do is graph that thing. Looks like choice A is going to be our answer, less than or equal to 4. Everything less than or equal to 4. All right, hard part of this problem is just setting it up and then using the greater than or less than. All right, what is the slope of the equation a equals a minus 4x minus 12 if it goes through the coordinate 2, -10? All right, this problem is tricky for a lot of people, but we should be able to do this. A couple things. If I want to know the slope of this equation, I need to know the number in front of x. That's what the slope is. So I need to know what a minus 4 is. That's one way to think about this problem. What is a minus 4? If you could find a minus 4, you would know the answer, okay? So if I'm searching for a minus 4, first off, I have to just find a. If I can find a, then I can find a minus 4. Well, how do I find a? I've got an equation. It's got an x, it's got a y, and it's got an a. It's got 3 unknowns. The only way for me to find this third unknown, a, is if I know the other 2, x and y. Do I know x and y? Well, if I know a coordinate, an x and y coordinate, then yeah, I do know an x and a y. So what I could do is I could plug in x and y and solve for a. Okay, so when I plug in y, I get -10 equals a minus 4 times x, remember x is 2, I'm using that coordinate, minus 12. Now we just solve for a. So I add 12 to both sides. That gives me a minus 4 times 2 is equal to 2. Now you could distribute the 2, but I think it's easier right here just to divide it out first. Opposite of multiplication by 2 is dividing by 2, which means they're inverses and they cancel. So I'm left with 1 equals a minus 4. If I add 5 to both sides, I get a is equal to 6. Sorry, I'm adding 4 to both sides. Why did I add? Something looked funky there. Let's back it up, right? I'm going to add 4 to both sides. There we go. Okay, so a is equal to 5. If a is 5, then plug it up here. A minus 4 would be 5 minus 4, which would be 1. So the slope is 1. Okay, now really, if you're really thinking about things, when you get it right here, you have a minus 4 is equal to 1. You don't have to solve for a if you know what the expression you're looking for is equal to. But usually most people don't see that, so go ahead and work that out. That's one way to do this, right? You got an equation with 3 variables, you know 2 of them, you plug it in, you find the one you don't know. That works great. Okay, now there is another way to work this problem. Okay, what you got to do is you have to, all right, we're going to leave all those things there, I think. Okay, so basically one thing I can do here is I can extract some information, right? You see how it's in y equals mx plus b form? What is the y-intercept of this equation right here? The y-intercept is negative 12. Okay, so the y-intercept is down here at negative 12. So 0, negative 12. I also know a second coordinate, 2, negative 10. Okay, if I want to know the slope of this equation, and I've got 2 points, just find the rise over run, right? Rise over run. You could do y2 minus y1. Don't forget you're subtracting a negative 10, so that means you're adding. Divided by y2 minus y1, right? I'm just calling this 0.1 and this 0.2, and I'm doing the formula here. I'm going to get negative 2 over negative 2, which is equal to 1. Okay? Just remember, you know a coordinate there because you know the y-intercept is negative 12. That's a coordinate. Also, if I drew a picture, I could kind of see that, yeah, I'm supposed to go up 2, and then I'm supposed to go over 2. So that means 2 over 2 is 1. Another way to do that problem. So this one's doable. You just got to really know what you're doing. You got to be confident. You got to know to look at this and say, oh, y is solved for. I've got something in front of x, and I've got something by itself. That tells me what I need to know, that this negative 12 is the y-intercept. All right, what is the equation of the line that passes through the following points? 0, 2, and negative 3, 3. All right, this is a standard problem here. We got to find the slope first. Okay, so we do y2 minus y1 divided by x2 minus x1. Okay, that's 1 over negative 3. So negative 1/3 is the slope. I can pick either of my points. If I have the slope and I have a point, I can use point slope formula. So y minus y1 equals m times x minus x1. Plug in what you know, right? We know the slope is 1/3, and I'll use my 0, 2 because it's nice and convenient. I like working with zeros. Right, there's my 0, 2. Then I just solve for y, because if you look at all your answers, they're not in standard form. They're all in slope-intercept form. So I distribute this. I get y minus 2 equals negative 1/3 x. Add the 2 over, and I get y is equal to negative 1/3 x plus 2. Easy as that. So just know where you're at and what you can use to get to where you want to go. So we're going to say that choice C is the correct choice. All right, which of the following is the equation in standard form of a line that is perpendicular to the line 5x plus y equals 10 and passes through the point negative 1, 1? All right, so we know we can find the slope of this line. And then we know that the line that I'm trying to find is perpendicular to that line. So remember, we would use the negative reciprocal or negative flip of that. So first, let's find the slope of this first line. Let's solve for y. Y equals 10 minus 5x. All I did was subtract that 5x over. So the slope of this line is negative 5. Now, I don't want to use that same slope. I want to use the perpendicular slope. So you have to remember that's a fraction in disguise, and that the negative reciprocal would be 1/5. So this is the slope that I want to use for our line. Okay? Notice how it goes through a point, and you now know the slope. Got to use point slope formula here. So y minus y1 equals m times x minus x1. Y minus the y coordinate. The y coordinate is 1, so y minus 1 equals the slope 1/5 times x minus a negative 1. Make sure you do the subtraction of a negative, flipping into a positive. Okay, I would go ahead and distribute here 1/5 x plus 1/5. Now don't forget, look at all your answer choices. See how these are all in standard form? I've got to get rid of these fractions. So look at your denominators, right? See how you have 5s in the bottom? Multiply the entire equation, left side, right side, everything by 5. That's going to kill off your fifths. So 5 times y is 5y, minus 5 times 1, which is negative 5. Now here's where the fifths cancel, right? The fifth on bottom cancels with this 5 out front and leaves you with 1x. Okay, same thing here. This fifth on bottom cancels with the fifth out here to leave you with a plus 1. So right now I'm really close. I've got to get my x over. Okay, so I subtract it over. I get 5 y minus x minus 5 equals 1. Move your negative 5 over by addition. So you get 5y minus x equals 6. Don't forget your x has to be in front. And we're almost done. Problem is, right, x, the coefficient of x, which is the a term, the x can't be negative. The coefficient of x is not allowed to be negative. So just multiply the whole thing by -1. All it does is flip the negative to a positive, flips this positive to a negative, and flips this positive to a negative. And there's your equation, written in standard form, no fractions, a is positive, and the x and y are on the same side of the equation with the number on the other side. So we get answer choice D. All right, which of the following systems of inequalities is shown by the graph? Okay, so, you know, basically, if you look at the solutions, the different possible answers here, you notice that all of these are the same. All these ones on the right are the same, okay? The only thing is different is there's some negatives here, some minus slopes. What's the slope of this line? Looks like -1, so that's coming down. Which way would down be? Well, this is positive slope, this is negative slope. Notice the y-intercept is 5, so up here at 5, that's got to be this line. This is line 2. So this needs to be line 1. And you can tell that as a positive slope. With positive slope, I can eliminate those two choices because those have negative slope. So really, I just need to kind of know which way to shade this thing. So I always try to test 0, 0 if possible, right? And 0, 0 is in this shaded region, which tells me that 0, 0 should work for both lines. Okay. All right, so I'm going to test 0, 0 into both my equations. So when I plug in the first choice, right, this is choice A, right, y is greater than 5 minus x. So when I plug in 0, 0, it should say something true. So when I plug in x equals 0, I get 3 times 0, which is 0, and 0 plus 3 is 3. That's why I get a 3 on the right side there. Over here, I get 0 is greater than 5 minus 0. All right, so this is true, and this is false, okay? Which tells me that it cannot be choice A. If I work the other one, you can see how the less than should have worked, because if I try B, this is y is greater than or equal to 3x plus 3, and when I plug in those numbers, I get 0 is bigger than 3, which doesn't work, so it can't be B. It's got to be C, okay? Now, this testing of points is a really, really easy way to do it. Alternately, you could try to graph the first one and test 0, 0. So if I graph the first equation, I would get this line right here. And if I test 0, 0, I want it to work. Anyway, this testing of points is a really, really easy way to do this. But what I was saying was you could figure out the sign either being less than or greater than or equal to based off of whether 0, 0 should work. So that tells you which way to put the sign. Anyway, testing is really the easiest way to do this problem. All right, if 3x plus y is equal to -10 and x minus y is 2, then 5x minus y equals. All right, so this is a system of inequalities. We've got x and y's, two equations with two variables. So we should be able to solve for x and y here. But I want you to look at this and see if you see anything. I've got 3x and 3x and y, and over here I've got x minus y. I'm trying to find out what 5x minus y is. So what combination of x's would work here? If I took one of these and two of these, and I added those together, I would get 5x. Question is, does that give me the right number of y's in this expression here, where I've got 5x minus y? Well, if I had one of these equations on the left here, that would give me a y. And if I had two of these minus y's, that would give me minus 2y. That gives me -y, which is what I want here. So if you can see that, this is a great way to do this problem. I need one of these plus two of these, and I want to add them together, okay? Because when I add them together, I get 5x minus y in that combination of one of these and two of these. Well, what is it equal to? This is -10, and this is equal to 2. So if I do -10 plus 4, remember, because I'm doubling this because I needed to have 2 of these, I get -6, which is my solution. So A. So look for this combination, this linear combination. 1 of these and 2 of these, if I add them together, I get what I need. That's the combination you want. Now, of course, if you didn't see that, this is very easily done using substitution or elimination. I think the easiest here would be elimination because we have the same variables, but opposite sign, right? If you look at the y's, you have 1 plus, 1 minus, they're going to cancel out. So if I add these two equations, I get 4x is equal to -8. That means x is equal to -2 when I divide both sides by 4. Now, how do I find the y? Go back and plug it in. Take the first equation, 3 times x, and replace it with what x is. 3 times x, so 3 times -2, plus y equals -10, and just find out what y is. So -6 plus y is -10. If I add 6 to both sides, I get y is equal to -4. Then I need to find out, ultimately, my goal isn't to ask what is the solution to the system or where do they intersect. I want to know what 5x minus y is. So 5 times x, which is -2, minus y, which is -4, gives me -10 plus 4, which is -6. Okay? All right. You could have also graphed both of these and saw the intersection point and then plugged in your x and y's into that expression. I think that's a lot of work. But again, maybe that works for you and maybe you didn't see the other way. So you got to do it the way that you see it. So that's okay to do it a different way than what I do. All right. So that's all I got for you. Thanks for being here. I appreciate it. And we'll see you next time.